안녕하십니까. 저는 Jim Elliott입니다. Good afternoon, ladies and gentlemen. My name is Jim Elliott, and I'm the Vice President of Memory Marketing and Product Planning for Samsung Semiconductor, headquartered in San Jose, California, which is at the heart of Silicon Valley. Again, I want to thank you to the conference organizers for the invitation today. It is my great honor and privilege to present on behalf of my company. My presentation today is entitled Empowering OEMs to Power Down, and I'll show you what I mean here in the next couple of slides. So my agenda is very forthright and to the point. I'm going to start talking about technology trends, talk about some infrastructure requirements, the environmental impact of those infrastructure requirements, and then lastly, what can we do to fix this or to mitigate this? So let's start by looking at technology trends. Mobile internet will be 10 times what the desktop or wired internet was. So in this next decade, our expectation is that more than 10 billion connected devices will ultimately be sold into the hands of consumers. These are all client devices. This goes beyond smartphones, tablets, PNDs, laptops, all these types of devices, even e-readers with Web 3.0. Wikipedia Web 3.0, always on, always connected. Social networking really being the glue that binds all these devices together. But we've heard a lot today about cloud computing. Think of the back-end infrastructure that is going to be required to connect these 10 billion devices over the next decade. Facebook. This is an amazing story. The impact of Facebook continues to grow. Anyone in here have a Facebook account? I imagine that there's a pretty good percentage of you. So look at these numbers here. This is now the #2 internet site in the world. More than 500 million active users, and people are now forecasting the day when this number goes higher than 1 billion users. Now Facebook defines an active user as somebody who's logged in the last 30 days. Look at those who use daily. 250 million people using daily, uploading more than 3 billion photos per month. 3 billion photos. More than 10 times that are being downloaded. Same thing for videos. 20 million, increase of more than double last year. But look at the bottom statistic there. That's the telling story here. Mobile access, more than 200 million people accessing Facebook via a mobile phone. 7x year-over-year increase. Internet usage is now being driven by social networking. If you look at the graph on the left, it shows social networking users now surpass email users. That actually happened in July of last year. And time spent on social networking, which is really the stickiness or the amount of time that people actually spend on the internet, is dominated by social networking and is no longer driven by email at this point. So now let's think about that. More than 10 billion connected devices, and let's look at the infrastructure required to power all these devices. Starting with the Web 3.0 impact on the traffic load. 2010, more than 21,000 petabytes per month. Without getting into too much technical jargon, 1 petabyte is 13.3 years of HD video, or almost 5 billion ebooks. And the internet community is now generating more than 21,000 petabytes per month. 40% CAGR, so this is increasing at a very rapid clip. This is going to have a massive or profound impact on infrastructure requirements as all these devices are connected. So we look at the server market growth. This is what is needed to sustain this. Very robust and consistent demand despite economic conditions. Virtualization and cloud computing are driving these data center builds that you've all heard about. So if you look at the petabytes of DRAM required, this year is about 200 petabytes, going to more than almost 1.3 thousand petabytes in 2015, more than 6x increase in the next 5 years. So 10 billion devices, more than 21K petabytes per month. What is the impact on the environment that moving all of these bits, videos, and pictures around drives at the back end? The biggest challenge for a data center is power consumption. You can see here a survey by the EPA shows that roughly 1.5% of total U.S. electricity usage in 2006, but there's a wide range of where that's going in the future, depending on how efficiently data centers are deployed moving forward. Now remember, for every 1 watt of data center power required, you need about 2.5 watts to cool that. And in 2009 Server expenditures were about 43 billion. Power expenditures were about 33 billion. So very, very high ratio of power to original purchase price. So if we look at the CO2 footprint of a data center, you can see the where data centers stack up compared to some of the other key major industries such as airlines, shipping, and steel plants. But the challenge the industry is facing now is look at the growth rate. More than 4x from 2007 to 2020 with an 11% CAGR in terms of the metric megatons of CO2. The good news is a lot of the IT and the regulatory communities are paying very close attention to this now. In the U.S., the Energy Star has now issued what they're calling version 1.0 for a server specification, which is about 2 watts per gigabyte of memory used. This is about 30% more efficient than standard servers. And if every server in the U.S. sold were comply with this, it would take about $800 million worth of energy out of the equation every single year. The good news is the version 2 draft is underway. The final draft is expected by Q2 of 2011 with effectiveness in Q4 of 2011. So adding all this up, 3% of U.S. electricity, if we look at the worst case scenario trajectory, what can we do? So let's look at a case study. So what I'd like to do now is introduce something called power savings with green DDR3. So this is a 30 nanometer class. This is the lithography used to fabricate the memory. 4 gigabit component density, 1.35 volt DDR3. If you look at this latest and greatest technology versus the incumbent technology, at the DRAM level, it's about 86% reduction in power. And at the system level, so this is putting the DRAM into a system with a CPU and a power supply and everything else, it's about a 44% savings at the system level. So again, very, very compelling reduction in power consumption. So if you look at a case study for a typical data center, let's choose, say, 25,000 or so servers at 48 gigabytes per, roughly 1.2 million gigabytes in aggregate. Data center A with the current solution, data center B with what we call the green DDR3 solution. So looking at power consumption, again, minus 86% at the memory level, minus 44% at the system level. Total cost per year going from 12 million to 6.8, a reduction of about 44% per year. I'd like to use Mr. Dong-Sung Kim, famous short track speed skater here in South Korea, to illustrate the performance gain by utilizing the latest memory technology. From a bandwidth perspective, almost double what we're seeing with the current install base. So again, faster performance and at the same time, less power. Cooling, again, talked earlier about the importance that this plays. If you look at the thermal image scan on the left, with the incumbent technology, it's about 92 degrees at its core. On the right, much, much, much cooler, somewhere in the mid-40s. Again, you're going to save about $2 million per year in cooling costs with energy-efficient memory. And then lastly, from a CO2 emissions perspective, at the memory level, minus 86%, system level, minus 44%. This is equivalent of about 1.4 million 10-year-old trees worth of oxygen absorption. Now, there's one other technology I'd like to introduce to you, and that's flash memory technology. And this has really been transforming industries. If you look at what it's done, remember the stack of floppy disks that we used to have to carry around? Now it's all on a USB drive. And same thing on the consumer electronics side. You can see the revolution of products that have come as a result of flash memory technology. So the question now is, what can flash do for the data center? So what we have is now, it's called an SSD, or a solid state drive. This is a hard drive replacement based on flash memory. No moving parts means much, much, much less power. Data centers and servers typically use a 15K RPM hard drive. Typically that surface is so hot you cannot touch it with your bare hands. So because the SSD is electrical operation only, very little heat and almost an 80% reduction in power. At the same time, the performance is almost 50 times greater than a 15K hard drive. So when you add these two up, you have your average IOPS of about 47 times faster, 80% reduction in power. You're looking at a IOPS per watt. Now again, this is what data centers need because they want to squeeze as much performance horsepower out of as few watts as possible. More than 200x increase. And what we're hearing now from a lot of leaders in the industry is one SSD can replace as many as up to 20 hard drives in a server installation. So again, very disruptive technology. So if we were to look now at the cumulative impact of this green memory technology, there's about 32 million servers in the worldwide install base in use today. If we were to replace every single one of these with green DDR3 as well as SSD, you're basically taking about 98 terawatt hours per year out of the energy equation, which is more than $6 billion per year in worldwide energy costs. And you can see the metrics down at the bottom. This is enough electricity saved to power about 8.5 million homes for 1 year. It takes about 18 coal-fired power plants out of the equation and is analogous to taking about more than 13 million cars off of the road. So the call to action, I think it's been great to hear some of the other dialogue this morning. There's a lot of disruptive technology that is available today. Green DDR3, Green SSD are just two that we're introducing now. And really strong TCO, this is that total cost of ownership, supports a very rapid adoption. This isn't something where we're looking for subsidies. It doesn't need to be subsidized. But really worldwide policies need to encourage the adoption, the much, much quicker adoption of green cutting-edge IT. Technology is evolving rapidly. The initial steps that we talked about are positive. And what we'd like to profess here is that we continue the momentum that's being generated now. And lastly, I'd like to remind you all that green is a journey and not a destination. So this is a continuous evolution along this continuum towards a green society and a green planet. And our belief is that green memory will continue to play a key role as building blocks for energy efficient infrastructure. So with that, I would like to say, kamsahamnida.